Good afternoon, grade 9. How are you today? You're fine? Very good. So, we are in Anupam Vidyasadan. It's located in Lazimpad, Kathmandu, and the students of the school are going to present in some particular topics. Last time I gave the students to present on group basis, but it was very haphazard. They were not presenting well. They just made some slides, brought and read like bound baji and went. No explanation, nothing at all. So Nitesh Kumar Yadav of this class, he suggested, sir, it's better to do individually. Then I said, okay, let's try. So from today, we will be having presentation twice in a week, Sunday and Wednesday. Actually, this presentation must be done yesterday, but due to holiday, yesterday we could not do it, and today we are going to continue this portion. And in today's presentation, Nitesh Kumar Yadav of grade 9 is going to present on the topic force. Without wasting time, let's welcome him with a great round of applause.
As you all know, it's me Nitesh Yadav standing in front of you for the presentation of Science Chapter Force. Now without any delay, I would like to start about my topic, force. Force. Before starting about the topic, I would like to just say about the rest. Rest is said to be a body is said to be in rest if it does not change its position with respect to the surrounding. Like as you all know that you are all in rest position as compared to the bench and desk. You are not. You all are sitting and you are in the rest position. Motion. A body is said to be in motion if it changes position with respect to the surrounding. As you know, I am moving here and there, and I am in the motion position as compared to the desk, bench, and all of you. Likewise, our next topic is force. The simple definition of force is pull or push. The pulling or pushing of something is known as force. Force is also defined as the pull or push of a body that changes or tends to change the state of a body from rest or uniform motion in a straight line. Force acting on a body can do following things, and it can change the position of a body. It can change the speed of a body. Like when we apply more force, then the speed of body actually speed of more than the previous one. It also changes the direction of a motion. As we all know, while riding the bicycle, we keep the pressure on the pedal, but with the help of the handle, we can change the direction. That is one of the example of force can change the direction of a body. It can also change the shape and size of a body. Like if we take any paper and if we apply their force, it will obviously change the shape and size of that paper. And there are two types of force. Force is classified as the balanced and unbalanced force. The force in which the number of force acting on a body does not change its state from rest or uniform motion in a straight line is called balanced force. As you all know, there is one game like pulling the rope from the two teams. When the rope is in the middle, then that we can say it's a balanced force. Likewise, unbalanced force means the number of force acting on a body changes state of uniform motion in a straight line. It changes its position or motion from one, like when it was, then from the rest it can be changed into motion, or when it was in motion it can be changed into rest. And likewise, our next topic is speed. As you all know that speed is the distance traveled per unit time taken. Mathematically, speed is equal to distance traveled by time taken. We can write it like speed is equals to distance traveled by unit time taken. We can also write it by S by T. Likewise, speed is a scalar quantity. Can anyone say what is scalar quantity? Anyone? Scalar quantities, those quantities which have only magnitude but no direction. Likewise, our next topic is uniform and non-uniform speed. Uniform speed is said to be if a body travels equal distance in each interval of time, then the body is said to have uniform speed. It means that when a body just move in a certain particular direction or in any direction and it change or it remain constant, the time and the distance remain constant, then it is known as uniform speed. Likewise, non-uniform means when a body covers unequal distance in equal interval of time in a specific direction is known as non-uniform speed. Likewise, our next topic is velocity. Velocity is defined as the displacement per unit time taken, and its formula is velocity is equals to displacement by time taken, and we can also write it in shortcut by S by T, and its SI unit is meter per second. SI unit is meter per second. Likewise, speed SI unit is also meter per second. But velocity is a vector quantity. It means that it has both direction and a magnitude. It moves on a particular direction. Likewise, our next topic is uniform and non-uniform velocity. Uniform velocity, non-uniform velocity means a body, if a body moves with non-uniform velocity, if the body covers unequal distance in each interval of time, then the body is known as non-uniform velocity, and it can be also known as variable velocity. Now our next topic is average velocity. Average velocity can be also defined as the total velocity, define a total displacement made by a body per unit time taken, and it can be written as total displacement by total time taken. Likewise, there is some difference between speed and velocity. Speed, it is a distance travel per unit time taken, but the velocity is the displacement travel per unit time taken. Distance travel per unit time taken means it can move in any direction, but displacement means in a particular direction. Likewise, it is a scalar quantity and it is a vector quantity. I have already discussed about the scalar and vector. Speed is always positive, but the velocity can be positive or negative. Now we are going to do some numerical problem related to speed. Acceleration means the change in velocity per unit time taken. Its formula is acceleration is also denoted by A is equals to V minus U by T, and its SI unit is meter per second square. Likewise, now we are going to solve some numerical problem related to acceleration. Example number 2. If a car traveling at a velocity of 4 meter along a straight line, speed of uniform to the velocity of 6 meter in 2 seconds, find the acceleration. Here the givens are the car is traveling at the velocity. It means that it is an initial velocity. Given initial velocity, it is denoted by U is equals to 4 meter per second along a straight line, speed of a uniformly the velocity of 6 meter. Then final velocity final velocity is denoted by v is equals to 6 meter per second, and the time taken is t. Time taken is also denoted by t, and it's 2 seconds. Now to find acceleration, now we have a is equals to v minus u by t. v means 6 meter per second. 6 minus 4 by 2. 2 by 2, then it's 1 meter per second square. The acceleration of a car is 1 meter per second square. Retardation simply means the negative acceleration is known as retardation. If the answer comes in negative, like if it was -1, -2 meter per second square, then it means the acceleration. Now we are going to solve the equation of motion on a straight line. Now we know that the we know the definition of, or we know the formula of acceleration is equals to final velocity minus initial velocity by time taken, but we can write it also by deriving this t comes here and it's multiply at is equals to v minus u. Now we will bring this u also here, plus u is equals to t. Now we have to rearrange this. v is equals to u plus at. This is the first equation of acceleration on a straight line. Likewise, the second equation is relation with sub and sub. We know that acceleration is equals to average velocity is equals to u plus v by 2, and there is one more formula of average velocity, and that is av is equals to total displacement by total time taken. Now from these two formula, the second equation have been formed. Now u plus v by 2 is equals to s by t. We can write it because this both are the formula of same equation. Now when we derive it, 2 multiply with s and this t multiply with u plus t, then it becomes s is equals to u plus v by 2 into t. This is the second equation of the line of motion. Likewise, the third equation of motion is derived from the first and the second equation, like v is equals to u plus at. This is the first equation, and s is equals to u plus v by 2 into t. This is our second equation. Now from this we have to put the value of v in equation 2. Now replacing replacing the value of v in replacing the value of v in equation 2 from equation 1, then s is equals to u plus b is equals to u 80. T. Now s is equals to 2ut plus 80 square by 2. Now these two will be cancelled, then s is equals to ut plus 1 by 2 at square. This is our second equation of motion, or third equation of motion. Likewise, the fourth equation of motion is also derived from the second and the third one. From the first equation, v is equals to u plus at. This is equation first, and the equation second, s is equals to u plus v by 2 into t. Now we have to replace the value of t from equation 1 in equation 2. v is equals to u plus 80. Now while deriving, 80 comes here and v minus u. Now therefore t is equals to v minus u by a. Now s is equals to u plus v by 2 into v minus u by a. S is equals to v square minus u square by 2a. Now s is equals to v square minus u square is equals to 2as. Now finally b square is equals to u, b square is equals to u square plus 2as. This is the fourth equation of motion. Likewise, now we are going on the next numericals. The question is that a bus travels from rest. If the acceleration of a bus is 0.5 meter per second square, what will be the velocity at the end of 2 minutes, and what distance will it cover during that time? And now by reading the question, we know that the bus has start from the rest, then its initial velocity u is equals to 0. Integral solution, we have initial velocity u is equals to 0 meter per second, and the acceleration is 0.5 meter per second. Acceleration a is equals to 0.5 meter per second square. Likewise, time taken t is equals to 2 minutes. If there is in minute or if there is in kilometer, then we have to convert them into meter and second. like 2 minutes is equals to 2 into 60. 1 minute is equals to 60 second. Then it's 120 second. Now we don't know the final velocity and the distance covered. So to find the final velocity, to find final velocity, to find the final velocity, we have the first equation of motion, that is v is equals to u plus at. We have the value of u, and that is 0. The acceleration is 0.5, and the time taken is 120 seconds. Now while multiplying, it comes 60 meter per second. The final velocity of the car is 60 meter per second. Likewise, our next topic is inertia. Inertia of rest is the property of a body by virtue of which it remains or tends to remain in the state of rest unless an external force acts on it. Like this body, we can say it is in inertia of rest, because if I do not use any external force, or if any external force is not applied, then it just remains at the rest position. Some of the example of inertia of rest are, we can stand, or when we stand or did loosely on a bus, and the bus suddenly start to move, we jerk backward of the bus. When the bus starts suddenly, and if we are standing or sitting, then we feel like a backward feeling. That is because of the inertia of rest, and because our legs are in the rest position, but our body is in motion. Because of that, we feel backwardness during the bus. Likewise, the next example is when a blanket is beaten, or when it is given a jerk, the dust particles fell down, because the dust is in the rest position, but the blanket is in motion. Because of that, the dust particles fall down. Thank you very much.